I'm Yue Qilin. Here I'm going to show you the solution of question 2 in homework 6. Question 2 provided as the joint density function of xy and the area of x and y is a circle like this. Problem A asks us to find B, so that above defined function is a valid joint density function. It's just similar to the formal question 1. That is, to make the joint density function is a valid function, that is, the integral in this area of fxy will equals 1. And we can get the expression, and to solve it we can get b equals 1 divided by pi. Question 2 asks us to find a serial of the expectation of x, the conditional expectation of x under the condition of y equals y, and so on. At first we have a look at the expectation of x, and it will equals integral from minus infinity to infinity minus infinity to infinity x multiply x multiply the joint density function of x and y and dx dy. So, from the figure of x and y, we can get the integral from y is from the minus minus square root of 1 minus square root of 1 minus x squared and to the square root of 1 minus x squared. This is y is from minus square root of 1 minus x squared to square root of 1 minus x squared, and x is from minus 1 to 1. So we calculate the integral, we can get ax will equal 0. So it is easily to see that x and the expectation of x under the condition y will equal 0 for every expectation of x under the y will equal 0. Due to the symmetry, expectation of y will equal 0, and the expectation of y under the condition x will also equal 0. Now let's come to the expectation of x and xy. This will equals the joint density function, that is 1 divided by pi. Multiply this gx xy, and the integral from the from y, and the integral of y from minus infinity from minus 1 minus square root of 1 minus x squared, and the square root of 1 minus x squared, and the x is from minus 1 to 1. And calculated, we can also get exy will also equal 0. For exy is equal 0, and ex and ey separately equal 0, we can easily find that they are equal, and that is xy and are uncorrelated.